You smell the storm before you see it. The air changes. Insects vanish. Somewhere beyond the trees, animals begin moving in the wrong direction. For most of human history, there was no forecast waiting when you woke up. No radar. No satellite. No cheerful symbol promising a 60% chance of rain. Your forecast was the world itself, and getting it wrong could mean losing a fire, missing a migration, walking into a flood, or watching an entire food supply disappear. So how did your ancestors predict the weather? The honest answer begins with a warning. Weather leaves almost nothing behind for archaeologists. A stone spear can survive for thousands of centuries. A cloud cannot. You cannot excavate a gust of wind, and no fossil preserves the moment someone pointed toward a dark horizon. But archaeology can reveal the decisions people made around changing conditions, while indigenous knowledge recorded in recent centuries can show what highly experienced human observers are capable of noticing. These are not identical kinds of evidence, and one should never be used as a simple copy of the other. Together, however, they reveal something remarkable. Your ancestors may have lived without meteorological instruments, but they were surrounded by instruments that breathed, bloomed, migrated, glittered, and changed direction. Start with the strangest weather station of all, the night sky. High in the Andes, farmers have long watched the Pleiades, the tight cluster of stars sometimes called the Seven Sisters. Around the southern winter solstice, they judge how bright and clear the cluster appears. If the stars look unusually dim, planting may be delayed because the coming growing season is expected to be dry. That sounds like astrology. It is not. In 2000, anthropologist Benjamin Orlov and climate scientists John Chang and Mark Kane published an analysis in Nature showing a physical connection. During some El Nino years, almost invisible high clouds contain enough water and ice to blur the Pleiades. Those same large-scale Pacific conditions are associated with reduced rainfall months later in parts of the Andes. A faint patch of stars can therefore become an early warning for a poor potato harvest. Would a prehistoric observer have understood high cirrus clouds or Pacific circulation? No, but understanding the mechanism was unnecessary. The useful knowledge was the pattern: dim stars now, difficult rains later. Watch it for enough generations, and the sky becomes a calendar with consequences. The moon offered another kind of forecast. At Pinnacle Point on the southern coast of South Africa, a team led by archaeologist Curtis Marion found evidence that humans were collecting shellfish around 164,000 years ago. Mussels and other coastal foods are easiest and safest to gather when the sea pulls back. The most extreme tides repeat in relation to the moon, especially near full and new moons. Archaeologists still debate exactly how deliberately the earliest collectors scheduled these visits, so you should not imagine a Stone Age tide table scratched neatly onto a cave wall. Yet regular use of intertidal food required attention to the sea's rhythm. If your ancestors connected a changing moon with an exposed reef, they were doing more than observing tonight's water. They were anticipating tomorrow's opportunity. The moon was not controlling the weather in a magical sense. It was revealing a cycle. That distinction mattered less than the meal waiting on the rocks. Then there were animals, nature's restless pressure sensors. Birds alter flight and feeding as wind, temperature, and air pressure change. Insects respond to humidity, heat, and approaching rain. Frogs call when moisture creates good breeding conditions. Herd animals move toward water, shelter, or fresh vegetation as seasons shift. Not every animal sign works, and many traditional sayings fail outside the place where they developed. But your ancestors did not need every sign to be universal. They needed a particular bird, insect, or herd to behave consistently in one familiar valley. Research with Mapuche communities in southern Chile documented 12 bird species used as indicators of approaching rain, snow, or storms. Some birds descend from the mountains before severe weather, prompting people to shelter livestock, collect firewood, or secure a harvest. This does not prove that Paleolithic hunters used those same birds or rules. It demonstrates the precision that local knowledge can achieve when many observers test the same living signals over generations. Imagine reconstructing one day. You wake beneath a hide shelter while the fire has burned down to red coals. The sunrise is pale, but a ring circles the moon as it fades. Thin cloud has spread high above you. The wind that normally arrives from the dry hills has stopped. Gnats crowd near your face. Farther down the slope, grazing animals have compressed into a tight group and begun drifting toward higher ground. No single clue announces a storm. Each clue is weak. Together, they change the decision. You do not cross the exposed plain. You move the sleeping skins away from the riverbank. You gather dry fuel before the air becomes wet. You warn another family expected to travel that afternoon. Then you wait. Is this prediction or simply caution? For your ancestors, the difference may have been meaningless. A forecast mattered only if it changed what you did. At Allard Saley in southern Kenya, Richard Potts, Allison Brooks, and their colleagues studied a landscape that repeatedly swung between lakes, grasslands, dry ground, and woodland. Sediment cores preserve those environmental shifts, while artifacts reveal changes in human behavior. After hundreds of thousands of years dominated by large hand axes, later groups used smaller, more specialized tools, transported stone across longer distances, and handled pigments that may have carried social meaning. The researchers do not claim that one thunderstorm invented new technology. The scale is much larger. Unstable environments rewarded flexibility, broader connections, and new ways of solving problems. Weather knowledge was probably part of that flexibility. When familiar water holes failed, information from another group could be more valuable than a sharper blade. This reveals a forecast your phone rarely shows you. Other people, your ancestors, could compare memories across ages and locations. An elder might remember where water remained during an earlier dry period. A hunter returning from distant ground could report that herds had already moved. A neighboring band might know a sheltered route through the hills. Shared knowledge expanded the area one mind could observe. The tribe itself became a weather network. Researchers Karen McNamara and John McNamara documented how elders on Arub Island in the Torres Strait read nesting and migration of birds, the movement of the Tagai constellation, and the onset of particular winds as parts of a seasonal calendar. The calendar did not divide the year into 4 boxes. It connected sky, sea, animals, plants, travel, fishing, and planting. A season arrived not because a printed date said so, but because several relationships changed together. That may be the most unfamiliar idea of all. Ancient weather prediction was probably not a collection of isolated tricks. It was a web. A red sky alone could mislead you. A noisy frog alone could mislead you. One unusual animal movement could mean almost anything. But when the wind shifted, the insects emerged, the clouds thickened, and an experienced elder recognized the sequence. The combined signal became harder to ignore. Modern forecasters also combine imperfect clues. Satellites measure clouds. Buoys measure oceans. Balloons sample the atmosphere. Computer models compare the present with patterns found in enormous archives. Your ancestors used different sensors and a smaller archive, but the basic problem was familiar. Gather uncertain evidence, compare it with memory, and choose before the future arrives. Of course, some ancient rules must have been wrong. Humans naturally remember dramatic successes and forget quiet failures. A ritual performed before rain may seem powerful even when the rain would have arrived anyway. Meanings could also be symbolic, spiritual, and practical at the same time. Calling a star an ancestor does not prevent you from using its appearance to time a journey. A story can preserve an observation long after the original observer is gone. What survives is not always a formula. Sometimes it is a warning wrapped inside a myth because a memorable story travels farther than a list of measurements. Here is the counterintuitive twist. Your ancestors survived not because they could predict weather perfectly, but because they assumed prediction would fail. They kept more than one food source. They moved rather than depending on a single permanent field. They shared across social networks. They watched several signals instead of trusting one. The true technology was not certainty. It was preparation. You now possess forecasts your ancestors could never imagine, built from machines watching an entire planet. Yet you often experience weather as an icon on a screen, detached from the wind against your skin and the birds above your street. The ancient lesson is not to abandon science for signs and superstition. It is to notice what a forecast is actually for. Information becomes valuable only when it changes a decision. Carry water. Delay the crossing. Protect the fire. Check on someone farther down the road. You still smell the storm before you see it. Now you understand that the smell was never the forecast by itself. The forecast was every clue, every remembered season, and every person who taught you what to do next.